Hello everyone. Today in this video we are discussing an important and interesting topic, that is analysis of variance Anova, which is there in 4th B pharmacy and pharmd biostatistics. Let's get into the video. Before going to the topic, please do like, share and subscribe our channel. Analysis of variance is a statistical procedure introduced by R.A. Fisher in 1920. According to R.A. Fisher, Anova is the procedure that is used to compare variance among the means of different groups. Analysis of variance is used for comparison of more than two populations. Anova is divided into two types. One is one-way Anova or one factor, two-way Anova or two factor. So today in this video we are going to discuss about one-way Anova. Anova is classified according to only one factor. In one-way Anova, we look at how different levels of single factor impact a response variable or a dependent variable. So now we will see what are the steps involved in one-way Anova. First step is we should state null hypothesis and alternative hypothesis. Null hypothesis is denoted by H0 and alternative hypothesis is denoted by H1. So if you see here, we took an example having 3 columns and 3 rows. So null hypothesis states there is no significance difference between the outputs. So here if you see, we written null hypothesis H0 equals to XA bar equals to XB bar equals to XA bar, whereas alternative hypothesis states there is a significant difference between the outputs. So if you see there, H1 equals to XA bar is not equals to XB bar is not equals to XC bar. So let's see the next step. Step 2. In step 2, we should calculate the variance between the samples. To calculate the variance, firstly we should calculate the mean. Mean is nothing but XA bar. To get the value of XA bar, firstly we should calculate the sum of total samples in column A. So the sum of total samples in column A is 12 divided by number of samples is 3. That equals to, we will get 4 values. In the same way, we should calculate XB bar value and XC bar value. Next, we should calculate the grand average of the mean. Grand average is denoted by X double bar. We will get X double bar value by dividing sum of all the means by number of columns. That is, we will get the value as 5. And the next step, in this step, we should calculate the difference between the means of the sample and the grand average, and we should square the value we get. So if you see here, like we discussed now, first we are doing the difference between the mean values and the grand average total and then squaring the value we got. Sum of squares between the samples, summation x bar minus x double bar square equals to 6. Next, in step 3, we should calculate the variance within the sample. In the step 2, we calculate the variance between the sample. So, step 3 also follows the same steps which we done in step 2. First step is to calculate the mean of the each samples, in which we will get the same values which we got in step 2. And in the step B, we should find the difference of each sample with the mean values and we should square the value we got. So if you see here, like in the step 2, we are following the same process in the step 3, but it is with each sample. So summation of x minus x bar square equals to, we will get as 24. We got the values of sum of squares within the sample and sum of squares between the samples. So next step is to calculate the ratio of F, which is nothing but we should draw an Anova table, one-way Anova table. In this table we will write the values of sum of squares, degrees of freedom, mean sum of squares and F ratio. Here we will take two different sources, one is between the sample and the other one is within the sample. So if you see, there is SSC in the sum of squares. SSC is nothing but sum of squares between the sample and SSC is sum of squares within the sample. MSC means mean sum of squares between the sample. MSE means mean sum of squares within the sample. Next, if you see in the column of degrees of freedom, mu1 equals to C minus 1. So C is nothing but number of columns. Number of columns we are having 3. So 3 minus 1 equals to 2. Within the sample, degrees of freedom is denoted by mu2, which is n minus C. N is number of rows into number of columns, that is 3 into 3 equals to 9, and number of columns equals to 3, that is 9 minus 3 equals to 6. SSC and SSE values we already got in step 2 and step 3. We will directly write them here. And mean sum of squares we will get by dividing SSC divided by C minus 1, that is degree of freedom. Mean sum of squares between the sample we got as 3, and mean sum of squares within the sample MSE equals to SSE minus N minus C, that is 4. F ratio we will get by dividing MSC by MSE, that is 3 by 4 equals to 0.75. Just have a look at the full forms of SSC, SSE, MSC and MSE. Next, as we got the F value, we should calculate the F value with the tabulated F value. The tabulated F value is 5.14, which is greater than the calculated F value. The last step is the conclusion or the decision, in which we will state whether it followed null hypothesis or alternative hypothesis. Next, there is also another process to do one-way ANOVA. In this process, the step 1 involves the same step which we did in the previous method, stating the null and alternative hypothesis. In the step 2, we should calculate the row sum of squares, that is summation xij square. That means we should calculate all the sum of squares of all the samples. In step 3, we should calculate the correction factor. So correction factor CF equals to G square by N. G square means grand total and N is total number of observations. In step 4, we should calculate the total sum of squares. Total sum of squares TSS equals to RSS, row sum of squares minus correction factor CF. Step 5 involves calculation of sum of squares within the sample. SSE equals to summation of TI square by NI minus CF, correction factor. Step 6, calculation of sum of squares between the samples. SSC, that is TSS minus SSE, that is total sum of squares minus sum of squares within the sample. Next, we should draw an Anova table which I showed in the previous method, and the last step is the conclusion. So if you see at this side, there are calculations. Ni, Ti square by Ni, summation of Xi, J square. So Ni means number of samples in row, Ti means total number of samples in a row. This is all about one-way ANOVA. I guess you have an idea or you got an idea regarding one-way ANOVA. In our later videos, we will have a brief knowledge about one-way ANOVA with examples, and I will explain how to do all the calculation in both the methods. You can follow any one method which is easy for you. You do hit the like button if you feel this video is informative and useful. Please do subscribe our channel for more pharma related notes.